Hello everybody. We continue on in lesson 4.3. We take our concept from a triangle adding up to 180 degrees and we extend it into what's known as the remote exterior angle theorem. So, any exterior angle is formed if we extend one side of the triangle. So as you see here, if we extend this side outside the triangle, angle 1 is my exterior angle in this case. It's the one that is literally outside the triangle. It is equal to the sum of the two interiors it's not connected to. That's the remote portion. So in this particular picture, angle 1 would be equal to taking the measure of angle 2 and the measure of angle 3 and adding them together. The literal idea of the words here, 2 and 3 are the remote interior angles because they are the ones away from angle 1. They're not connected to it. This blank space angle that's right here is the interior angle that is adjacent and connected to 1. It's the one we don't need in this problem. 2 and 3 are remote. 1 would be totaled by angle 2 and angle 3 added together. As far as problems go, literally set up that concept. Always remember the phrase, the outside exterior angle is the sum of the two that it's not connected to. It makes it very easy to set up problems. So in this first example here, in this first picture on the left, angle 1 is the outside one, and it is equal to the sum of the two that it's not connected to. In this case, 76 and 52 degrees. This is a direct computation. The measure of angle 1 would end up becoming whatever you get for 76 and 52 added together, which is simply 128 degrees. Meanwhile, in the second picture, notice that there's a slight change to the setup. As long as you read the phrase out loud to yourself every single time, you'll have it perfect. The outside angle, 104 degrees, is the sum of the two that it's not connected to. Angle 1 added to 79. The reason you have to be careful with the setup is this one actually has an algebra step to be done. You need to subtract the 79 from the 104 in order to reach the answer. We end up getting 104 minus 79, which comes out to be 25 degrees. But that is the idea for each one. Outside angle is equal to the sum of the two it's not connected to, and then just once you've got your setup, either directly add them together or work out a little bit of algebra. Speaking of a little bit of algebra, let's get into example 2 here. The same setup, notice the problem, the value of x and find the measurement of each angle. So we are going to have to go plug this x back in at the end of the problem, but first things first, we have to actually set up and solve it. The outside angle, in our case, 18x minus 15, must be the sum of the two interior angles it's not connected to, the remote ones. So it must be the sum of 13x minus 11 added to 4x plus 1. On the right-hand side of our equation, let's simplify a little bit. We do have some like terms to deal with. So 13x and 4x for a total of 17x. Negative 11 and positive 1 to create minus 10. And now let's start moving things around. If we subtract 17x off from the problem, we end up at x minus 15 equaling negative 10. And then add the 15 over. We end up discovering that our value of x is equal to 5, which is one of the answers that we were asked to find. The value of x is 5. We are also asked for the measurement of each angle, so we're going to go plug it back into each of these angles. We can verify our work that way. So 13 times 5 comes out to be 65 minus 11 will make this angle 54 degrees. While 4 times 5 will be 20 plus 1 will make this angle 21 degrees, which means immediately if I do not get 75 for this one when I plug it in, I know we've made a mistake somewhere. 54 and 21 add up to 75. this has to become 75 for plugging it in. 18 times 5 will be 90, minus the 15 comes out to be 75, exactly as we expected. So we know we've done this 100% correct. Last but not least, as far as practice problems go, we have one last example here, a series of triangles all put together with the direction, find each of these 8 angle measurements using all the rules that we know. This is a key thought. Don't let new information overrule all the old stuff that you know. Vertical angles still exist, linear pairs still exist. You have parallel marks in this picture, so alternate interior and same side interior. All these different angle pairs still exist in this picture. On top of, we can do a triangle is 180 degrees. We can do an angle on the outside is equal to the 2 it's not connected to on the. We have lots of options available to us. The only drawback to having all of these choices in this problem is going to be we're probably not solving it in sequence 1 through 8. We are probably going to have to go do bouncing around the problem going, well, I know this is true because of this reason, and then this is true because of that reason, and so on. Your chances of actually solving this right in sequence 1 through 8 are slim to none, to be perfectly honest. So let's start looking at our picture, what we got here. I see 4 triangles. We got parallel marks for the top and bottom line, so we know we can always do some parallel work if we have to. And we've got an intersection in the middle here, angles 2, 3, 5, and this 71 degrees that's given. So let's just start looking through what we know. You can do this problem in several different orders. I'm honestly just going to show you what do I notice first as I start looking through the picture. And I'm going to do the easiest one first. Angle 2 has to be 71 degrees thanks to vertical angles. It's directly across from the 71 that's listed. We'll just take that one right off the list, 7 to go. If I know angle 2 and 71 match, I can solve 3 and 5, the other vertical pair, just as easily. Angle 2, 71 degrees, plus angle 3 must be 180. They are the 2 forming this straight line in the picture. If we subtract 71 off from 180, we end up at 109 degrees, thanks to straight line. So we can fill in angle 3 is 109 degrees, but look at the picture, 3 and 5 are directly across from each other. So as a result, angle 5 is also 109 degrees, again, thanks to it being a vertical angle pair. So for angle 5, we'll fill in 109 degrees. And just like that, in quick, easy steps, we've got 3 of the 8 answers already. Now, if you look around your picture here, in the top triangle, I have everything I need except for angle 1, because I have an answer for 2. In the left triangle, I have an answer for 3, so I could solve 4. And in the right triangle, I have an answer for 5, so I could solve 6. My only problem I'm going to run into is 7 and 8 are unknown, and they are down here at the bottom of this triangle. I'm going to have to do a little bit of clever work for the bottom one. But let's take care of the 3 triangles, because that will solve everything real quick. The top triangle. So all of these are due to triangle being 180. We're just going to do all of them right in a row. The top triangle, 47 plus the 71 from angle 2 plus angle 1 is 180. So angle 1 will end up being, we'll just go subtract those off. 180 minus 47 minus 71 comes out to be 62 degrees. And then we'll do the left triangle. So we have 36 plus the 109 we got from angle 3 plus angle 4 must be 180. So again, we'll go subtract those off. 180 minus 36 and minus 109 comes out to be a 35 degree angle for angle 4. And then we can do the right side triangle. We've got 42 plus the 109 that we got in angle 5 plus angle 6 being a total of 180. And again, we'll just do the same step. We'll subtract those off. 180 minus 42 minus 109 comes out to be a 29 degree angle. 29 degrees for angle 6. We've covered 6 of the 8 answers using nothing more than some old skills with vertical and straight line and the triangle skill that we learned here. That's it. That's all we've done so far. Now, angles 7 and 8. Well, we got a problem here. I can do one more triangle question. We know 71, but we need to solve either angle 7 or angle 8 before I can finish the triangle work. And this is where the parallel marks are going to kick in. We have 2 parallel lines cut by a transversal. Angle 1 and angle 8 are a pair of alternate interior angles. And in case you forgot, alternate interior angles are congruent to each other. So if angle 1 was 62 degrees, so is angle 8 immediately. So we have 62 degrees for angle 8, thanks to the fact that they are a pair of alternate interior angles from the parallel line and the transversal. Now that I have angle 8, let's go finish the last triangle thought. 71 plus the 62 that we just got from angle 8 plus an unknown angle 7 must be 180 because they are forming the 4th triangle in this picture. If we go subtract those off, 180 minus 71 minus 62 leaves me 47 degrees for angle 7, which now, if you want to get really clever, if we use the other line, we could have argued alternate interior that way as well, 47 matching angle 7 down here at the bottom. There are lots of ways to approach these kinds of questions as long as you have a correct definition or theory of some kind. Vertical lines, straight line, alternate interiors being congruent, triangle 180. As long as you have a correct theory of some kind or definition, you can use any of them to get them. The goal is ultimately to get these 8 angle measurements in the box here. If you get those 8 values correct, you are good to go for the lesson. If you've got any questions on the concept, make sure to ask your teacher, and see everybody in the next section.